There are many cases to the ambiguous case of the law of sines. First, what is the ambiguous case of the law of sines? If you are given two sides followed by an angle, that is what's considered the ambiguous case. In the ambiguous case, the first example, which I think is the easiest to understand, is when you have no triangle. And that occurs when the contained side is less than the altitude, or the side opposite of the angle given is less than the altitude. Please understand that the altitude is b sine A, which I did several problems explaining that with area, so you might want to watch that video before you watch anything about the law of sines to understand what an altitude is. And keep in mind that the contained side does not have to be A, and this A does not have to be A. I mean, this could be X, and then this would be, the contained side would be X, and the altitude would then be X. So my advice is to understand what an altitude is, what an opposite side is, what a contained side is. But if that contained side is less than the altitude, you have no triangle. And the reason is, I mean, think about if you ever, when you were a kid, and you try to make a fort out of blankets, and maybe a couch or something. If you tried to put a pole in that fort and it was too tall, then the fort wouldn't work because the altitude or the height was too tall. So let's look at an example with actual numbers in it, an actual algebra. The example, visually makes sense because your altitude is just swinging right here. You have a swinging altitude and it never hits the ground. It's just kind of, where do I go? And so to look at this algebraically, what we're going to do is draw a triangle with A being 7, B being 9, and the angle being 54. Now, I want to remind you again, if this was side M and this was side angle M, I would draw this exactly the same way. I'm just labeling it, and that's what I meant by you really want to figure out what I'm talking about contained side and angle. So looking at this picture, you have the 54 on the left. I always draw it on the left no matter what the labeling of the triangle is. Across from that is 7. And then B, whatever this is. Again, this doesn't have to be B. This could be the side O. I still would put it here. I always draw the picture the same way to keep it in perspective. And so my altitude is always just drawn to this bottom base down here. And this base is not needed to be found right now. I just need to know what the altitude is. So the altitude would be, using the triangle that you see inside of the triangle, the interior triangle, would be opposite of hypotenuse, or altitude, over 9. And so sine of 54, opposite of hypotenuse, would be altitude over 9. I would solve this by multiplying both sides by 9, just as we did earlier. And again, I'm going to remind you, you're going to want to watch those area videos, because I assume that you have, looking at this. And our altitude is 9 sine 54. After you solve that, which comes out to 7.281. Well, 7.281 is greater than this opposite side, and that's the problem, right? If the contained side is smaller than the altitude, you have no triangle. You just stop and you write it down that there's no triangle. Well, let's say you missed that. If you try to do this problem anyway, the calculator would say undefined. It's good not to waste your time and type it into the calculator, but this is almost a no-lose situation, because even if you don't know this and you try to type it into the calculator and try to actually do the problem using the law of sines, using the key ratio of 7 divided by sine of 54, and then you try to find any of these other angles, it will say error, undefined, or it might say error domain or something. But this is the reason why, because the contained side, the side opposite of the given angle, how about we say it like that, is less than the altitude found by doing the regular right angle trig of that interior triangle.